Hello everyone, welcome back to our Spring Boot series. Today I'll be talking about transactions, how to define them, using annotations, using the programmatic way. I will talk a little bit about ACID and how to roll back correctly any transaction. And then I will provide a code walkthrough to see these features implemented. I will not be talking about two different subjects because they are more at the architectural level and they should have their own video because they are really extensive. One is the transaction propagation, meaning what happens when you have a method, one that should call another method, two in a different bin, and one supports transaction and the other doesn't support transaction, or maybe each one of them, they have to create different transactions or their own transactions, or maybe one of them want to participate in transaction, and so on and so on. There are at least, I don't remember now, between 5 and 7 types of configurations that you can create. What happens when you start a transaction or not in one method and you call another method that decides about its own transaction behavior. And the other subject will be about isolations. There are several different levels of isolations, not usually between 4 or 5. There's some discussion. It depends how you target them. But the isolation is related with how the transactions can see data from each other. And this, of course, needs a complete video to explain them because there are a lot of complexities behind this. There is an explanation about how transactions work behind the scenes inside the server, so you understand when to choose one isolation level or the other. Usually people think that, okay, I have an isolation level, it's about, I have one transaction, so it's atomic, so nothing changed my transaction when it's being applied. That's wrong. It depends on the isolation level, and I will explain in a future video. So let's start our simple video here, but quite useful because you will understand how to apply in Spring Boot transactions in a programmatic way, in a declarative way, and do it I don't like the word correct, but the best way regarding the context of your application. So let's start with the ACID properties of transactions. ACID properties is regarding how what is a transaction and what are the properties of a transaction. Nowadays, this is not the only system. ACID, there is another one which is safe, but it's really for distributed architectures, and I will address that one in my architecture series. So let's target here the ACID. So ACID are the initials of these 4 words. One is atomicity, meaning that all operations succeed or all fail, meaning that transaction should be atomic. I expect that if I have 10 inserts and it fails on the 6th, all the previous 5 should also be rollback and not inserted on the database. Consistency, meaning that if something fails, the database should remain valid. Meaning that, for instance, if I remove a department, I expect to all the people that work in that department be also removed, or maybe I can't remove the department without first remove the people that work there. So it's this, of course, this is related with foreign key and primary key. There are other constraints that exist on database, and all of them are regarding with consistency. Isolation is transactions do not interfere, control concur issues. This is what I was talking about moments ago about isolation levels. I will address this in the future. And durability, committed data persists even after crash or power loss. This is it's not easy to explain in 30 seconds, but I will try. Okay, so you understand what is durability. Durability is not regarding the disk or the storage. It's regarding how server applications, server database work. When you send data to a database, the first thing database does is to check, okay, what do you want? You want some rows from a specific table. So it reads all of this data to memory. So everything that happens in a server, it's in memory. That's the first thing that you should know. Now, when you do an insert, update, or delete, or any operation, it does not go to the tables directly. The data is read from the tables, but they are not inserted or updated on the tables because the cost will be too much on the performance. Imagine thousands of inserts and updates happening at the same time on the same table. That will be crazy for the disk. So what will happen is this data will be inserted in a log file specifically designed for this. So they start a transaction, they put a mark and say, okay, transaction will start. Then there were two or three inserts, and then if everything went well, there will be a commit. If something wrong happens, there will be no commit. There will be no checkpoint, there will be no mark. Imagine now that the server goes down. And what happens when the server starts, well, every transaction that were marked with commit will be put now to the database. And the other ones that were not marked with an end, they will be rolled back and completely ignored. But you can say, okay, this happens for when there is crash. What happens when there is no crash, since the data is not created on a database? So there is a process, let's say, that runs every 30 seconds, 1 minute. Of course, it's configurable, that will go through all these files, check which transactions are not yet on the real database and are committed, and they are put on the tables of the database. That's how database work. In this way, it's not constantly targeting the table, but only once in a while. And there is no out of sync of data here because all of the data, it's in memory. This is what means durability. Sometimes people don't know about this. I talk with myself when I start to understand. I see no one explained to me how the database works. But I was a trainer for some time about databases, database administration, and things like that. So I start to understood so much better these concepts, and all of them make sense, and the ACID properties start to make more sense when we have these explanations. So why are transactions important? First, ensure atomicity, like we saw before. That's why we use transactions. It prevents partial updates. Of course, it's implicitly from the atomicity, and they are crucial in operations like managing money. It's something that we don't want to lose. Those scenarios where we say, okay, I will do these 3 things, and all of them should happen. Otherwise, there will be problems. For instance, transaction management options. How can we use transactions in Spring Boot? We have 2 ways. One is using the annotation transactional. It's the recommended way. It's called declarative because we declare the annotation in a method. And there is also the programmatic when we need more finer control. And for that, you can use something like TransactionTemplate or Platform Transaction Manager. Both of them, they are used. In our example that we'll have in a moment on our code walkthrough in our application, I will show you the declarative and the programmatic way. Declarative transaction sample, let's see something like this. So imagine that you have this method and you put this annotation transactional here. And now we can do these updates. Maybe you are a very attention person. You say, hey, there's something wrong with this design. You have a service with database here. Yep, that's right. And I will tell you why. There is a comment here that you can read. But at the end of the day, I just want to provide one slide that can explain the transactional, and at the same time to explain to you what this annotation transaction should be used at the service level, not on the repository level. If you think for a while, it makes sense, because most of the times you want to do operations in different tables that probably are addressed with different classes in repositories. So it makes more sense to have the transactional at the service layer here, and then here you call the repository methods. Of course, it will not be something like JDBC update. It will be something like insert category, update entity, create a new transaction in different repositories, but all of them will participate on the transaction because at the service level you create this transaction. So these updates and JDBC template here injected, it's a really bad practice in real life. I just put it here for educational purpose, but don't use it. And if you are following my videos, I think I don't need to explain more about this. So let's see some use cases. Let's say order placement with inventory update. Imagine that you are placing orders, which means you insert an order here and you expect the product to exist. But imagine that something fails when you update the inventory and you are decrementing the stock, the number of items that you are buying when you insert this order. If you don't have a transaction, of course, there will be out of stock in a moment, but you don't know about it. It seems that you are accepting orders, and since you are not decrementing the stock, you are always have stock, and that will be a false assumption. That's why transaction is useful in these scenarios. Another one is logging, mainly audit logging. When you change a user, you want to register who did this operation. You want to have someone that is responsible for this operation. That's what audit means. So you want to always insert the audit on the same transaction as the action that you are taking on the user. And another one is batch inserts in transaction. If you see my previous video about batching on the JDBC template, you will understand the need for the transaction. You are inserting thousands of rows, and you also understand better the that I provided before. Maybe you want to split the 1000 in 100s so the transactions will not be heavy to the database, and you can insert blocks and you can log, and later you can resume from the latest batch that failed. But see my previous video if you think it's useful for you to understand how batch works using JDBC template. But again, the transaction is quite important. I don't know if you want, in this case it's just for this for, but maybe you have a list of lists of transactions that you want to use here. Now you need to roll back. How you can roll back? Usually, if you throw a runtime exception, not a checked exception, but a runtime exception, there will be an automatic rollback. How this works, again, in 30 seconds behind the scenes, I don't want to go into much details, but I think it's useful for you to understand some of the internals. So if there is a problem, it will be better for you to troubleshoot. When you put the transaction, this annotation transaction, what happens is Spring Boot behind the scenes will create a proxy around your method, meaning that when this faulty transfer is called, it will not be this method, but another one that probably it's inside the try-catch. And when it detects that there is a runtime exception, it will roll back for you in a programmatic way. Because at the end of the day, it's not an annotation is just a label. It doesn't have behavior. It's what some entity or some method or some class does with this annotation. And in the case of Spring Boot, it's a proxy that is created that will handle the methods that contain this transactional. And the implementation of those methods in the proxy, one of them is do a catch on runtime exceptions and will roll back for you the transaction. So what happens to the transactions that are not runtime, which are the checked exceptions? Usually they don't roll back the transaction. It's quite, there is some discussions about this. People don't understand why, but that's the way it is. Usually checked exceptions don't participate in the rollback. But if you want to force the rollback, you can do something like this. You put here this rollback equals, and you put here the transaction, the exception that you want, that if it is thrown on this method, it should be also participating on the rollback. Another way to do this, for instance, an alternative to do this is if you want to more finer control. Let's say that you have something transactional and there is a condition that makes the transaction fail. It's not about an error on the database. Something on the business that says, okay, if this user has this value, there's something wrong here. Maybe it's not an admin, so I should roll back at this time everything that started here on this method. For that, you have to use this transactional aspect support. There are other ways. Usually this one, it's the most popular. So you have transaction aspect support. You get the current transaction status, and it's something that I will show you how you can define this. Here you don't need. Here you just write this here. Set rollback only. So this indicates again to the proxy when it checks this status, say, okay, this transaction that I'm managing is marked for rollback, which means even if there is no exception, it reached the end, I will roll back the transaction anyway. Okay, that's another way for you to perform the rollback. So there is, of course, some careful that you should have. First, imagine that you're calling the transactional method from the same class. You have a method that is marked as transactional on the service, method 1, and the method 2 also contains a transactional. What happens when the method 1 calls the method 2? The problem is the method 1, it's under a proxy, okay? And that's a problem because the other one also contains a proxy, but it will be ignored, which means that the behavior will be unpredicted. We never know what will happen. If it's on the same table with the same connection, things like that, maybe the rollback will be applied to both because it will be a kind of a status to the database. But imagine that the method is going to a different database and it's a transaction manager using a two-phase commit. Probably it won't work. That's why it's a good practice to, and I saw this in some projects, sometimes people, they create 2 layers on the service level when they need transactions. One is, let's call it orchestrator. Let's say if you need to call multiple methods in services that are transactional, one way is to create a more generic method that call these methods. And this one, it's marked with transactional and the other ones are not. And what I saw is that Usually the methods that constitute transactions will be on the layer of the orchestration, and the other ones that are only service that will participate in transactions don't have the annotation. That's one of the ways that you can do. Another one is an advanced one that we'll explain when I address the other topics, because it's regarding the proxy. You can use some tweaks on the annotation transaction and make sure that you will participate, let's say, on the transaction. But it's quite advanced, and it has some peculiar things that should be addressed careful. So it's not a good idea, let's say like this. Maybe if you need to manage a lot of transactional stuff, Spring Boot, try to go to this architecture where you have two layers for the service. One which is orchestrator that handles transactions, and the other layer has the common methods of your service, and you don't put there the annotation transaction. And in this way, you can call the methods as you wish. Of course, you don't have to use always the first layer. If you are doing some simple CRUD operation like insert, updates, and deletes, maybe you don't need the two layer, but you want to create this layer orchestrator for the use cases where the transactions are important. Okay, that's one solution that I saw one team once doing, and it seems elegant and quite easy to understand. And it was when you read the code, it makes sense. Okay, that's one way to address. So let's see now a programmatic transaction example like this one. For this, we have to inject the platform transaction manager like this way to auto-wire, and let's do a manual transfer. First, you have to get a class called default transaction definition. I will talk about this class when I talk about isolation levels and things like that, because it contains properties for the transaction. And this transaction status, for instance, it's the one that we saw here. It's this one, current transaction status, that allow us to provoke, for instance, rollbacks. Okay, and you can see here that when we add this manual transfer, you just start here. You don't have to put a start transaction. You just use update, and then you commit here. Okay, and that's it. Because you have this get transaction definition, so your transaction starts, and now you have this transaction manager commit here, and you pass the status. If this status is something like this, again, set rollback, of course it will roll back, but probably now you can do it yourself. For instance, like this, transaction manager rollback status, you can do it. You don't need to inform this approach useful because of the annotation. You don't have control of the start or the end of the transaction. You only have control on the in this case on the annotation. But here you have full control of the commit and rollback, so there is no reason for you to use that annotation. There are ways for you to write clearly, begin transaction, things like that, but usually this approach always works. But if you go to document, don't get surprised if there are other ways to implement the programmatic transaction. Okay, this is just a slide showing the different ways, but internally they look the same. If you go to the transactional, here you have your service marked as transactional. So there will be a begin. You don't write the begin, but it's implicit there. It is being done by the transaction manager. Where is this transaction manager? It will be on the proxy that is generated by your transactional annotation. Then you perform your updates, and then there will be a commit at the end of the method, and that's it. When you do programmatic, of course, you call the method. It will execute the transaction template behind the scenes, which are these. This is one way of doing. There are other ways, but this is what implicit here. Now you do your updates, and then you commit, or maybe you roll back. That's you to decide what you want to do. So where should transactional go? Again, on the service layer. It's the preferred location. It coordinates multiple repository calls, keeps data access clean, so the repository only targets what it needs. It doesn't have to understand the business concept behind these operations to the database, and aligns with domain-driven design. Okay, avoid transactional in repository. It's not a good practice because it demands your repository to know more about business than it should. Okay, do this instead, and now you can see that it's nicer than my previous slide. So you auto-hire your repository, you put the transaction, and now you call the save, sign roll, or other methods associated with your repository. So it will follow a pattern that I will address in my series of patterns called Unit of Work. It's quite popular, more I think on the C# world than Java, but I also saw this implementation in Java, the unit of work. If you are using unit testing, quite useful, the transactional, because it can clean if an exception fails, is thrown on your method, meaning that your test fails by an exception. Since the runtime exception automatically rollbacks the data, so it's always a good approach if you are accessing data in your tests to put the transactional, so you don't have to clean database. It will be automatically clean if the test fails. Okay. Best practice, use declarative or programmatic when possible. Everything in Spring Boot it's declarative, so try. If it's not possible or you need more fine-grained control, of course you should go programmatic. Keep transactions at service layer. Avoid self-invocation of transactional because of the proxy complications, as I said previously. Use proper isolation only when needed. I will address this in a different video. Okay, usually the default isolation, you should see it on the documentation, but it should be something like read committed if you start to read about isolation levels. So in summary, we talk about JDBC template supports declarative and programmatic transactions. I put here JDBC template because I'm addressing JDBC template at this time, but I will move to JDBC client and Hibernate. But everything that I talked here applies also to all technologies in Spring Boot that access the database. Transaction is preferred for simplicity. Apply transactions for this kind of systems: logging, order, fund transfers, batch inserts. There are four different types of application, and usually they probably need transaction. Not all of them need transaction. If you are doing just a simple insert, by default the database creates a transaction for you. But if you need more than one operation, each one from the point of view of database will be a transaction. But if you control the transaction, the beginning and the end, the database waits and your transaction overrides the default behavior of the database. Okay, and again, don't forget, place transaction logic in the server layer. So let's do now a code walkthrough. So I've created here on the entities service, okay, 3 types of transactions. I call them, one it's without transaction. So I'm creating an entity here, okay, then there is a category, and here I'm throwing an exception, okay, but there is no transaction here, neither manual, neither annotated, which means that this entity will be sent to database. You have this save, then this happens and this code will never run because it's different from null, the entity here. But what we'll see in database is that this data will be there, and this won't, of course, but because it was never executed. But probably it's not something that we want. There are cases that probably it's not a problem, but usually if you have a method that is doing something, we expect that everything in the method should be executed if it's just a script-oriented method, because you can see you have an entity and then a category. There is no business logic here, just this crazy test for me to make it fail and prove my point. Okay, now I created a, which is called the with annotation, with the transactional one. It's the same code, and we expect to not see this entity there, because there will be, it's a runtime transaction, so it will throw a transaction, and the proxy behind this transaction should roll back, should go to database and say to database, please ignore the entity. And of course, this code will never be reached. And now from the programmatic point of view, meaning you get the default transaction definition, which is the definition of the transaction, and we can configure things like isolation level and similar. And the transaction status means what is the current status of the transaction. Maybe it's committed, maybe it's marked for rollback and things like that. And again, we start with the new entity, you save the entity, and if it's different from null, should roll back, otherwise we will run the category and we do the commit here. So the commit only happens if it reaches this point. If it doesn't reach this point here, okay, it should be rollback because of this runtime, because this runtime will move to this sketch, and this sketch contains this line, rollback. I'm stating clear what I want. So let's see this executing. So I created here a set of posts which are on this REST control. In this REST control, I have transactional 0, transactional 1, and transactional 2, which they call those methods. One, it's without transaction here. This one, it's the with this transactional with the annotation, and this one, oh, maybe I'm jumping. This is with the transaction, and this is without the annotation. This is with the annotation, not annotation, and without the transaction. These are the three methods. 0, I could say, you can see here, transactional 0, transactional 1, the one with the transaction, the annotation transactional, and this one, it's without the annotation, it's the one with the programmatic way. So let's first get all the entities that are in the application. So you can see that we have 1, 2, 3, 4. This is the latest one. And from the categories, the latest one here, it's the 5. We have 5 categories here, and we are trying to create an entity and a category. So let's call our first one, which is the transactional 0, which is the one that there is no annotation, there is no transaction whatsoever. So let's run. Of course, we receive a 500 because there was an error, but let's see what happens from the database point of view. So when I get now the entities, you can see that it created the entity because there is no transaction. And if you go to the code, this is the exception, but this statement is executed, and by default the database creates a transaction if we don't create one. So I created a transaction for this one, and there was a commit after the save. Then this exception happened, so there will no problem. So the code is working as expected. So be careful with this kind of things. Okay. Now let's see what happens with the transactional 1. Transactional 1, it's the one that it's annotated. So let's run this. Of course, there is an exception that we see the 500, but from the point of view of the categories, let's see if a category was created anyway. Nope. You can see there is no entity created here. It's the one, this entity is the one created by our first call, not the second call. You can see here the one that it's annotated with a transactional, throws this exception, but this transaction invalidates this first insert on the database. And you can see the name, it's entity 1, and the latest one is entity 0. And now let's see the programmatic way working. So we play here. Again, we have a 500 because of the exception, but let's see what happened here on entities. Again, didn't enter the entity, which means this code here that we have here, it's working as the same way as the annotation. We create the entity, we save here, then there was this exception logged here, error occurred while inserting entity and category, and the transaction was rollback. So these are the three most popular scenarios when you handle transactions. Not transaction, transaction with annotation, and transaction in a programmatic way. There are other things that we can explore in other videos, but for now, I think this is quite useful. You can apply this to your projects, and I think maybe 80% of your needs on your code probably can be addressed with what we talk about in this video. So thanks again for watching this video. Hope to see you in my next videos. Please subscribe, share with your friends. It's always a motivation for me to create more videos. Thank you for watching, and I hope to see you in my next video.